All right, howdy, howdy. We're going to continue moving forward on the unit with polynomials, and we're going to get into basically review of an older lesson, but throwing a polynomial spin on it. And the older lesson was from function notation. And so we're going to evaluate polynomial functions and using the same exact thing we had done previously with function notation. And I'm going to set up the lesson with the following question. For each function, I have two of them. For each of them, what we're going to do is evaluate different things depending on what I'm asking, and then represent the answer in ordered pair format. So it's the same thing we have done previously, just with a polynomial spin on it. And so the concept remains the same. The two functions we have are p of x and q of x. So depending on the question I'm asking, that will determine the function that we're going to use. So if you look at question number 1, I'm asking p of 3, which means I'll substitute into the p of x function, and q of negative 2 will go into the q function, and the fractions will go in there as well. So we're going to use that, and there's really not too much more to it. We're just going to represent the answers in ordered pair and move on. So if you look at question number 1, I'm asking, what is p of 3? I mean, this is actually a question, p of 3. And so it means we're going to use the function that is p of x. And we see that p of x is 2x squared minus x plus 7. So p of 3 is going to be 2 times 3 squared minus 3 plus 7. All right, so let's see how that works. It's just a substitution concept. And notice for substitution, the only thing that changes is the variable that we are substituting. Everything else remains the same. Okay, so with substitution, we only change the variable. Everything else remains the same. And from then on, we have to use order of operations. Okay, so once we substitute order of operations, we're good to go. And remember how order of operations works. Okay, GEMDOS or PEMDOS or however it is that you want to remember it. But grouping symbols first, then exponents, multiplication, division, addition, subtraction. And so from here, that's what we're going to use. So we'll have 2 times 3 squared happens to be 9, and then minus 3 plus 7. And then we have our multiplication. 2 times 9 is 18. And so we have 18 minus 3 plus 7. We crunch those numbers in no matter which manner. 15 plus 7 is 22. So the result of that 22 is 22. So the question again, what is p of 3? P of 3 is 22, but we have to remember we're going to evaluate it using ordered pair format. So we're going to list the result as an ordered pair. And that's going to be important for a later lesson. So when x is 3, the result is 22. Input, output. And that's the concept. So we'll run through the other questions, and then we'll get into using it in a more real-life example. Number 2, the question is asking what is q of negative 2. And so we're going to use the q function. And we saw from the beginning that q of x is negative 3x squared plus 2x minus 3. So q of negative 2 just means we're going to substitute negative 2 for x and then use order of operations. And again, remember, the only thing that's changing is the variable. Everything else remains the same. Okay, and that's going to involve some sign work. Okay, so from this step, again, we use order of operations, which means we're going to have exponents first. So negative 3 times negative 2 to the second power is positive 4. And we can also use multiplication here. 2 times negative 2 is negative 4. And then our minus 3 remain untouched. And now we can use multiplication. Negative 3 times 4 is negative 12, minus 4 minus 3. And then we crunch our numbers whichever way. So negative 16 minus 3 is negative 19. So the result is negative 19. But again, we're going to use an ordered pair format. So when x is negative 2, the result is negative 19. Ordered pair. It exists in space. Okay? Because this equation can be represented by a graph that exists in two-dimensional space. So that's how it works. Okay, moving on to number 3, we have p of negative 1/2. All right, so we're using the p of x function again, but now we're using a fraction. Oh no. And so p of negative 1/2 simply means we're going to substitute every x we see with the fraction negative 1/2. And yes, that will involve fraction work. So notice the substitution piece here. All right, this is minus x, but x is negative 1/2. So we're looking at minus negative 1/2. That's the key element of substitution that so many students just make mistakes on. So we want to make sure that we are substituting correctly. This is minus x, x is negative 1/2. Everything remains the same except for the variable. So please be careful in that step. So now what we'll do is multiply first. Negative 1/2 squared is positive 1/4. That's right. If you don't believe me, check it out. 1/2 times 1/2 is 1/4. Okay? So we got to remember how to multiply fractions as well. Now we have a minus negative 1/2, which turns into plus 1/2, and then plus 7. And now we can use the multiplication piece. 2 times 1/4 is 2/4. So we have 2/4 plus 1/2 plus 7. And hopefully you look at the number 2/4 and something in your brain clicks, because 2/4 is the same thing as 1/2. So we have 1/2 plus 1/2 plus 7. How convenient is that? I made this stuff up. It just works out really well. So what's 1/2 plus 1/2? A whole 1. 1 plus 7 is 8. So when x is negative 1/2, the output is 8. How convenient. So that is the ordered pair for when p of x, p of negative 1/2. All right. So we have one more for the original question, and we'll get into kind of a word problem. So now we're asking for q of 1/4. So we're going to use the q of x function. Excuse me. But we'll have q of 1/4. So q of x, of course, negative 3x squared plus 2x minus 3. Q of 1/4 simply means we will be substituting 1/4 for x. Everything else remains the same. Now we're going to get into some fun fraction work. So hopefully you don't let fractions scare you. That would be great. All right, so we have our setup. We have now substituted our x. Now some people get confused here because they want to clear fractions. Don't do that, because it only works for solving equations. So anyway, we're going to simplify what we can. Exponents first. 1/4 squared is 1/16. And then plus 2/4, and then minus 3. All right, so at this stage we can now multiply our fractions. Negative 3 times 1/16 is actually negative 3/16. And then plus, we can call that 1/2. I'm cool with that. It doesn't matter. From here. So from here, this is where, again, students, you get confused. You can't clear the fraction, so don't do that. Can't clear the fraction, just crunch the numbers. Right? All we're doing is crunching numbers. All we're doing is crunching numbers. It's elementary level arithmetic. We have to have a common denominator, right? So for all of these three things, we have a common denominator. And the common denominator between all three numbers is going to be 16. Right? So we have negative 3/16, which remains the same. But how do we turn 1/2 into a fraction over 16? It's going to be something over 16. Well, how do we get from 2 to 16? We multiplied by 8. Right? And if we're going to multiply that by 8 to get 16, we have to multiply the numerator by 8 as well. And we have 1/8. So 8/16 is 1/2. All right, we're going to do the same thing with minus 3. How do we turn that into something over 16? How do we turn minus 3 into something over 16? Well, minus 3 is minus 3 over 1. So how do we change that into a number over 16? We multiply by 16 to get to there. That means we multiply 3 times 16, which is 48. And so we have minus 48 over 16. And so now we have our units of measure, our denominators, all set up. 16ths, 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 and now we can just combine them. So we have negative 3 plus 8 minus 48 16ths. right? And then we can crunch our numbers from there. So negative 3 plus 8 is 5. 5 minus 48 is negative 43. And so we end up with negative 43/16. See, it's not so bad. And of course, students will say, well, it looks easy when you do it. Of course it looks easy when I do it, because I know what I'm doing. How about you do it? Don't just stare at me. You do it. All right, so we have our result. So when x is 1/4, our result, negative 43/16, which is a number that exists in space. Okay, this is an ordered pair on a graph. So that's working with fractions. The process remains the same. So now what about word problems, right? So I know some of us hate reading. I don't understand that, but I get it. Well, I mean, I acknowledge that that exists. I don't understand that, but whatever. So here we go. We have a word problem. The height of an object is modeled by an equation. Okay, this is a realistic equation if gravity didn't exist or wind or anything. Well, gravity did exist, but like wind resistance and all that stuff. P of t is equal to negative 15t squared plus 985. Now, what does that mean? What we're going to do is find the height of an object after 3 seconds if t is actually time measured in seconds, and p of t is actually measured in feet. Okay, so if t is measured in seconds and p of t is measured in feet, what's the height of the object after 3 seconds? Well, if 3 is the amount of seconds and t is time, guess what t is going to be? It's going to be 3. So all we're saying, seriously, you look at this word problem, all I'm asking is find out what p of 3 is. I mean, it's seriously what the question is asking. But you have to overcome your crazy fear of reading in order to see that. So if p of t is negative 15t squared plus 985, then p of 3 is going to be negative 15 times 3 squared plus 985. And the rest is crunching numbers, right? And the question is, well, what's the height of the object after 3 seconds? And so we're going to figure out what the height of the object will be after 3 seconds. And that's where the handy-dandy calculator comes in. And so we can start doing order of operations. So negative 15 times 9, because 3 squared is 9, plus 985. All right? So negative 15 times 9 is negative 135. So negative 135 plus 985, what would we get? That's a 0 and a 5 and an 8. All right, so 850. So we would end up with 850 feet. So when p is 3, when the time is 3, the height is 850 feet. But what is this? This is an ordered pair, right? So how are we going to answer the question? The question is asking, find the height. Well, the answer of the question is actually 850 feet. That's the answer of the question. So always make sure you answer the question. That is such an important rule to follow. So for word problems, don't be scared. Just, it's a lot of words, right? You're like, oh no. And then there's this crazy equation. You're like, oh no. Just be careful. Read carefully. It's simpler than you imagine. And it's just like function notation. So everything works out super well. That's it for this lesson. We're going to use it in the next one. Take care.